All right, today we're diving into one of the most mind-bending and honestly kind of terrifying ideas in all of physics. It's called the Boltzmann Brain Paradox, and it's an idea that threatens to unravel, well, everything we think we know about reality itself.
So let's just jump right in with a question that gets to the absolute heart of this thing. Are you sure that your memories are real? I mean, everything. Your childhood, what you had for breakfast this morning, even the memory of clicking on this explainer a minute ago. Are you sure it all actually happened? Or could it all just be an illusion?
Okay, so let's define the main character in this whole cosmic nightmare, a Boltzmann brain. So what is it? Imagine a fully formed, self-aware brain that just pops into existence out of pure chaos. And here's the kicker. It comes complete with a full set of false memories, a whole life that never actually happened. 1 second, there's just a random void, and the next, poof, there's a brain floating in space that thinks it's you.
Right, so how in the world did physicists get to such a wild, almost unbelievable conclusion? I mean, the idea that our reality could be a complete illusion? Well, it all boils down to this huge clash between what we think we know about the universe's past and what our best theories predict about its future.
Okay, so basically, our best science gives us two completely different ways that an observer, like you, could come to exist. Path 1 is the story we all know and love, right? The Big Bang kicks things off with a super-ordered low-entropy state that leads to stars, planets, evolution, and eventually you. Path 2 is way weirder. It says in a universe that's completely chaotic and disordered, what we call heat death, a brain like yours could just randomly assemble itself by a fluke quantum fluctuation. Now here's the terrifying part. If the universe lasts forever, that second path isn't just possible. It's statistically way more likely to happen.
To really get our heads around this, we actually have to travel back in time. We're going to the 19th century to look at the work of a truly brilliant and, as it turns out, tragic physicist named Ludwig Boltzmann.
So Boltzmann's huge breakthrough was figuring out why time has an arrow, why it only seems to move forward. You know, why you can scramble an egg, but you can't unscramble it. He realized it all comes down to statistics. He defined this thing called entropy, which is just a measure of disorder. And a system, any system, tends to move toward more disorder for a really simple reason. There are just vastly more ways for things to be messy and jumbled up than for them to be neat and tidy. It's not a magical force, it's just pure, simple probability.
And what's really wild is that back then, Boltzmann's ideas were, well, they were totally controversial. I mean, he was in these fierce intellectual battles with some of the biggest names in physics, guys like Ernst Mach and Wilhelm Ostwald, who, get this, didn't even believe atoms were real. So here's Boltzmann trying to convince the world that reality is governed by statistics and probability, and his opponents are saying the very building blocks he's talking about don't exist. He was way ahead of his time.
So to explain the crazy amount of order we see in our universe, that super low entropy state near the Big Bang, Boltzmann came up with a really radical idea. He basically said, what if the universe as a whole is actually in a state of maximum chaos, of total equilibrium, and it's been that way forever? He argued that our entire observable universe, everything we can see, is nothing more than a tiny, temporary, random fluctuation. We're just living in a rare little bubble of order inside an infinite ocean of cosmic chaos.
All right, let's fast forward to today. We're going to see how this old 19th century idea suddenly becomes a huge problem for our best modern model of the cosmos. And the scene of the crime, so to speak, it's not in the past. It's in the universe's distant future. So our standard model of cosmology, the one that fits all our observations best, it predicts a pretty lonely future. Thanks to this mysterious thing we call dark energy, the universe's expansion is accelerating. And it's just going to keep going, forever. Eventually, all the stars will fizzle out, galaxies will drift so far apart you can't see them anymore, and all that will be left is a cold, dark, empty void. A state of maximum disorder, that heat death we talked about. And the key thing is, this state will last for eternity. That's an infinite amount of time for random stuff to happen. And this is where things take a seriously terrifying turn. Because you have to remember the golden rule of infinity. In an infinite amount of time, anything that is even remotely possible doesn't just happen. It will happen. In fact, it'll happen an infinite number of times.
So here's the absolute gut punch of the paradox. In that infinite empty future, what's a more likely random fluctuation? Is it for an entire universe with trillions of stars and 14 billion years of complex history to pop into being? Or is it for the absolute minimum thing required to have a thought, a single, lonely, conscious brain to pop into being? Well, the laws of physics are crystal clear on this.
Smaller fluctuations are exponentially more likely than big ones. It's not even a close contest. The single brain wins, and it wins by an infinite margin.
And when you look at the numbers here, you really start to see the scale of this problem. Look, the time it would take for a brain to just randomly assemble it's beyond astronomical. It's a number so huge it makes the current age of the universe look like a split second. But, and this is the whole point, in a universe that lasts forever, a long time becomes meaningless. Eventually, those brains will form, an infinite number of them, in fact. And that infinite number of phantom brains will vastly, overwhelmingly outnumber the tiny, finite number of real humans who evolved the normal way.
Okay, so at this point, you might be thinking, this is just some weird philosophical game, right? But it's not. This isn't just a quirky thought experiment for physicists to puzzle over. This is a genuine crisis. It's an idea that threatens the very foundations of how we do science. This whole mess has a name. It's called cognitive instability, and the logic is a real snake eating its own tail. Follow me here. Step 1. Our best scientific theory predicts that you are almost certainly a Boltzmann brain. Step 2. Okay, if you are a Boltzmann brain, then all your memories, all your perceptions, all the scientific evidence you've gathered, it's all fake. It's just random noise in your phantom head. Step 3. But wait, our best scientific theory was built on all that evidence. So, step 4. If the theory is true, then we have zero reason to believe the theory is true in the first place. See? The theory completely destroys its own foundation.
The physicist Sean Carroll put it perfectly, and I'm paraphrasing a bit here, but he basically said, a theory that invalidates the minds of the theorists who created it cannot be a good theory. And he's right. It's the ultimate self-own. It's a logical dead end, a complete paradox.
So, does all this mean science is just broken, that we should all pack it in? Well, not quite. Physicists take this threat so seriously that they've come up with several possible escape routes, ways the universe might be structured that save us from this nightmare scenario. And these aren't just wild guesses. They're actual active areas of research in cosmology. And these solutions pretty much fall into three main categories. First, there's the idea that maybe the universe has a self-destruct button, it just doesn't last long enough for these brains to become a problem. Second, maybe our math is wrong. In a multiverse with infinite possibilities, maybe we're just not counting observers the right way. And third, maybe there's just some new physics out there that we haven't discovered yet that changes the whole game.
So, escape route number 1 is this idea called vacuum instability. The theory goes that our universe might exist in what's called a false vacuum. The best way to picture it is to imagine a ball sitting in a little dip on the side of a huge hill, not at the very bottom. It's stable for now, but it's not truly stable. At any moment, quantum mechanics could let it tunnel through and start rolling down to the real bottom. If that happens, the laws of physics could change everywhere, instantly wiping our universe clean and starting a new one. No infinite future, no Boltzmann brain problem.
Another possible out is something called the measure problem. This one's a bit more abstract, but basically when you're dealing with an infinite multiverse, trying to compare one infinity to another is really tricky. You can get different answers depending on how you count. So some physicists are working on new mathematical rules, new measures, that tell us how to count observers properly. And under some of these proposed rules, it turns out that normal, evolved observers like us become the overwhelming majority, and those spooky Boltzmann brains become so rare they're basically irrelevant.
And finally, a third escape hatch has to do with dark energy itself, that stuff that's making the universe expand faster and faster. What if it isn't perfectly constant? What if it can change over time? Well, if that's the case, it could lead to a totally different end for the universe. Maybe it gets stronger and leads to a big rip that tears every single atom apart. Or maybe it fades away. Either way, it would change that long, quiet future and potentially stop the Boltzmann brains from ever having a chance to form.
So, what's the big takeaway from all this? Why does this crazy idea even matter? Here's the most important thing to understand. Physicists don't actually believe we are Boltzmann brains. The paradox isn't a prediction. It's a test. It's like a giant red flag. If a physicist comes up with a new, beautiful theory about the universe, but it ends up predicting that we should all be Boltzmann brains, they know the theory is wrong. It's broken. It gets tossed in the trash. It's one of the most powerful tools we have for weeding out bad theories about the cosmos.
And that leaves us with one last, really profound thought to chew on. You notice how many of the best solutions to this paradox involve the universe ending, that it can't last forever? So, could it be that the ultimate fate of our cosmos, its own potential self-destruction, is actually a necessary feature? A kind of cosmic safety switch built into the laws of physics from the very beginning for the sole purpose of making our own existence logically possible? It's a wild idea,
a universe that has to die, just so that we can say we ever truly lived it all.